Hi everyone, this video is about the motivation for our project and how we went about achieving it. Our team's focus for this project is on weather prediction. So how do we predict weather? We have many patterns behind weather and lots of data for us to observe these patterns. One way that weather prediction has advanced is through the use of machine learning. With sufficient data and computational power, machines can identify and learn patterns in the weather. A common machine learning model used in this field is the neural network. These are networks modeled after the brain, which, similar to the human brain, comprise layers of neurons, where information is passed in a feed-forward manner through the network. These neural networks are great at prediction and classification. However, they are not so great at handling time series data, that is, data that is separated and affected by time. We focused on two specific architectures of neural networks, which work well for time series data. They are the time-delayed neural network and the recurrent neural network. The time-delayed neural network combines time-delayed inputs with current inputs. Each layer is a combination of the previous layer and processes inputs at a larger temporal context than the previous layer. The TDNN extracts patterns in weather across different timescales. The recurrent neural network, on the other hand, is a repeated application of the same neural network as implied by the word recurrent. It combines input with the previous state of the neural network and models the idea that future weather is influenced by current and previous weather. So what was our methodology in approaching this project? We collected weather data from 1998 to 2018 and trained neural networks with the first 19 years. We then used our model to predict the weather patterns for 2018 and compared it with the actual recorded weather in 2018. Here's what we found. As you can see, both RNN and TDNN are able to predict the general trend of temperature over the year. However, we observe in both cases that the predictions made are accurate for periods when the temperature does not fluctuate much, but they are not as accurate during periods of high temperature fluctuation. In order to improve this model's predictions for periods of high day-to-day temperature fluctuation, we would need some knowledge of why temperature changes and what other factors influence temperature. This use of TDNN for long-term predictions brings us interesting applications. Long-term forecasting can help predict climate states accurately, which has many real-world applications, like planning crop rotations and accounting for seasonal changes. Thank you for your attention, and we hope you enjoyed our project.